Ladies and gentlemen, welcome back to another episode of Cosmic Catastrophe on Revolution.radio. I am your host, Diamond, from the Oppenheimer Ranch Project. And joining me today is my lovely co-host and partner, Leah Shaper.
Hello.
I've got some interesting lighting happening up here.
It's like the angels are behind you.
We got a great show for you today on the #1 listener-supported internet radio, Revolution Radio, where information never sleeps. Check out revolution.radio, and we are always in Studio B, noon Mountain Time. So check us out. We also replay these podcasts on our Rumble channel, Magnetic Reversal News, with all of the visuals that we will be discussing on the radio show today. And we've got a great one. We are going to be discussing a new paper that just came out that redates the opening of the Atlantic. And it's actually the final phase. It would be the rupturing of the North Atlantic, which finally allows salty water to enter what is probably a series of extremely deep Rift Valley lakes. Do you know what those are?
No.
They're happening now in Africa. You know that the eastern part of Africa is ripping apart?
Yeah.
So what happens about 350 million years ago, this is the story, and we'll get to that in detail at the end of the show, that Africa smashed in to North America and pushed up a huge mountain range higher than the Himalayas, which was all the way up there about 320 million years ago. And so, like at New York City, they would have a mountain range right at the center of Manhattan that would have been about 26,000 to 36,000 feet high. Mm. And so then for a period of about 120 million years, because the mountain range is so high and just formed, just like the Himalayas, it's the highest, steepest points on Earth that weather the fastest. And in 120 million years, this baby weathers almost flat again to just like some foothills, which are the Appalachians. Mm-hmm. And also the mountains, like say in England and all those little crappy mountains in Africa as well.
Crappy mountains.
Yeah, they're all weathered down now they've been weathering now for 320 million years. Hmm. So they weather down kind of flat, right? And somewhere around 200 million years ago, something happened where the orogeny reversed. So an orogenic event, which we'll talk about, the Akkadian orogeny, the 320 million year old, is when two plates collide. That's an orogenic mountain building event. This is the orogeny right here. After it calms and it weathers, that's a passive plate boundary. It's not even a plate boundary. It's like one big plate. Mm-hmm. You know, and they named them all these crazy names like Pangea and Gondwana land and whatever the heck the other names are. So it's calm and stable for 120 million years, weathering flat. And then whatever mechanism brought them together now starts to reverse. And as you pull away, big fractures in the crust occur, like vertical. I mean, they go down a mile sometimes. And because of these are instantaneously the lowest points on the crust, what do you think happens? All of the water on the surface flows into these cracks. Mm-hmm. And what you get is lakes that are 8,000 foot deep, a rift lake. And it keeps getting deeper and deeper, opening as the plates pull apart. And then they start to merge. All these fissures merge up into a string of lakes. Mm-hmm. And then what they claim is that finally the crack became big enough. So it actually was splitting from south to north, the Atlantic Ocean like this. And in the final phase, which this paper is about, is when the north opened up and the seawater rapidly rushed into this rift valley.
Yeah.
So the rift lakes, the surface level of the lake is probably way below sea level because you need trillions of gallons of water. It's going to take millennia to fill these holes. They're huge. You know, like the Marianas Trench depth kind of lakes.
Yeah.
Yeah, you can't use an anchor in these lakes.
Fascinating. I mean, it's so interesting to like that is happening in real time in our lifetimes. I mean, obviously very slowly, but it's interesting that we get to kind of observe that in Africa.
And which is it. What is interesting is all up and down the East Coast are these 220 million year old to 200 million year old Triassic Rift Valley basins. The one where I live near, I actually lived in it. in Montgomeryville, Pennsylvania, that Triassic basin is called the Newark Basin. It goes all the way up to Newark, New Jersey, all the way through Pennsylvania to the south. And that's where they mine all the crushed gray stone and red stone that you see in landscaping for, the gray and crushed and the red stone.
Yeah.
It all comes from those Triassic quarries in the east. And there are sequences in these quarries that you can do stratigraphy with, and they are thousands of feet thick, thousands of feet of sediment. And the lake was always super deep. So the sediment is always representative of very deep lakes because it's the finest muds that settle out in those. Right on the edges is where you get all the sand deposit, and it's only mud on the bottom. So even though there's thousands of foot of sediment, almost a mile or more, I think is estimated, the lake was still deep. That's how deep these lakes are.
Yeah.
And then it's really weird because the sun is coming in and I'm totally washed out.
That's pretty funny, actually. It's like there's something cosmic happening behind you.
So the basins that are all up and down the East Coast with these deep lakes are inland. Montgomeryville is 120 miles inland from the Jersey Shore or so. And then the crack is further out that actually made the Atlantic. So while the plates are pulling apart, there's fissures happening all over, not just the main crack. Because when you make the main crack and you're pulling apart, big chunks of the crust slide down too, forming more Rift Valley lakes. And those are the ones that get preserved, the shallower ones that are further away from the crack, which is why we have this incredible stratigraphic dictionary on the East Coast of the US of this early time period of dinosaurs.
Yeah.
Now, what we're going to get to later, as I get cosmically washed out here, is the fact that dinosaurs started as big as mice, like little chickens. And it took millions of years for them to grow to the size of Tyrannosaurus Rex. And we're going to throw out some interesting theories a little later about what might be going on there. Do you have any comments before we dive in?
No, let's go.
All right, let's go. How do I do this? I might not be able to see the screen at some point.
Well, I was wondering, can you actually see your screen so you can tell what you're doing?
Not really. So here's the paper. Gigantic mud waves buried deep beneath the ocean floor reveal dramatic formation of the Atlantic when Africa and South America finally split. Enormous mud waves buried under the Atlantic seabed formed 117 million years ago as the Atlantic opened up. Now, why do you suppose they're mud waves after that whole diatribe I just said? Are you there?
I'm here. I've read the paper, so I have an idea. So
the paper doesn't really talk about where I'm getting to. With the story I just told you, why would there be mud waves and not sand waves?
Because of the involvement of water? I don't know what you're getting at, so just please answer your own question.
These were deep fissures in the earth filling with mud for millions of years. They were Rift Valley lakes filled with mud. So when the ocean rushes in the first time, it's going to push. Remember, there's thousands of feet of mud on the bottom of these lakes. It's going to push that mud and make these waves as the ocean rushes in. It's not going to be sand. So the mud waves immediately, from a sedimentologist or a stratigrapher that knows these were Rift Valley lakes filled with mud, that the only time you're going to get these gigantic mud waves, it's not going to happen from just water flowing in a lake. It's when the rift opens and the sea level rushes in. Like if the lakes were 200 feet below sea level, when the crack opened, can you imagine the cascade of, so the entire weight of whatever oceans were there would rush into this hole.
Yeah.
It would be very turbulent. It would mix up all that mud, and then it's going to make these huge features. These are not normal features.
No, they're enormous.
Yeah, they're mega features.
Yeah.
The only time you get these mega features is when something extremely catastrophic or unique happens.
Yeah.
Okay, cool. All right. So they kind of show a picture here of what these giant mud waves in the sediment cores look like. But it will mean really nothing to the layman.
No, but I mean, we could give an idea for the listener of the sizes that we're talking about of the waves. Which,
yeah, the discovery of these buried mud waves off the coast of Western Africa reveals that the Atlantic Ocean was born 4 million years earlier than scientists previously thought. And because these waves are literally signaling the moment it happened.
Yeah.
Yeah. And
well,
so, go ahead.
I was just thinking a minute ago, imagining the moment that it happens where you sort of reach that tipping point and all that water can flow in.
There's tons of videos online of dudes where there's these tidal rivers where they cut a little tiny slot and then have you seen those? It erodes into a gigantic canyon.
Right. I haven't seen those, but I can imagine. Yeah.
And then they surf in them. Yeah. So it looks like that only at a mega scale.
Mm-hmm.
And so when this happened, these waves occurred. Each were hundreds of feet high and over a half a mile long. And they were caused by the mixing of extremely salty water from the southern hemisphere with that lake water from the northern hemisphere as South America and Africa tore apart. Now, if that's hard to visualize, they got some really great graphics here.
Yeah.
And so here we are. You can see where we're connected, right? And to the south here in Southern Africa and South America, there's already the Atlantic forming. So this is supposedly happening 200 million years it begins, and it slowly moves to the north and widens. It does not get to this salty ocean yet, though. So it keeps rifting wider, but there's a pinch point here up in the north. Can you see my cursor?
No, I can't actually, but
that's unfortunate.
Like you said earlier, the rift is widening at the bottom first, and the last bit of it to separate is up at the Guinea Plateau.
Yeah,
that last point where Africa and South America are touching.
Yeah, and here's the final progression. So in the final moment, and then they can date the stratigraphy here, is when those giant mud waves are going to be pushing. So the big rift is going to happen at the pinch point, but the mud waves are going to be deposited miles inland from the event, because the event is going to be so forceful, no deposition is happening at that shallow neck, the pinch point.
Yeah.
You're going to just have massive flow of water in. It's going to be miles afterward that the turbulence can settle down, and then you're going to deposit these mud waves.
I have a question. The paper mentions that the Guinea Plateau,
I'm not sharing the pictures. Why didn't you tell me?
I'm seeing the pictures.
Oh, well, I wasn't sharing them on StreamYard.
Well, and I couldn't.
Are you seeing them blown up like this?
I mean, sure, if you want to call that blown up.
That's the way they were the whole time I was talking about them?
The way it looks right now is the way it looked to me a minute ago, yes.
That's weird. I wasn't sharing. Okay, so what's the question?
The paper mentions that the crust of the Guinea Plateau is thinned. That indicate, suggesting that it was once thicker and now it's thinner. What would cause that?
What would cause that? Well, it would be caused by a mid-ocean ridge forming, because that's what's happening here. Do you see the red line in the graphic?
Yeah.
That would be a point at which upwelling from the mantle is occurring and volcanic activity is occurring. So the initial stages to kind of jumpstart this rifting. So remember, from 320 to 200, it's a passive margin. It's not doing anything but eroding. At 220 or 200, for some reason, there's a huge upwelling of magma from the mantle, which pushes. So this is the passive margin. It's sitting flat. that upwelling pushes the crust up before it starts splitting.
Mhm.
And what happens when you push the crust up? Just like the orogeny, it starts
Mhm.
weathering. So that would thin the crust as it spreads
Okay.
apart. It's the
Yeah.
upwelling that pushes the crust up. It would then erode off and then it would open.
Okay.
So it's the initial upwelling before the split occurs. Kind of, it's like a little magma bulge.
Yeah.
And then you'll get erosion there. So that would be thinning of the crust.
Mm.
Why did they mention it?
I'm not exactly sure. It kind of seemed like it was just in passing because they were talking about the differences on the north and west boundaries of the Guinea Plateau versus the southern plateau. Basically, those differences being an indication of how this last bit of separation occurred.
Yeah.
I have to find that.
Yeah, it's very interesting.
It was in that context. I don't know if it was exactly relevant, but it might have just been a passing mention. Here I have it here. So they talk about the plateau is bounded by two ocean crustal domains with different ages. So the ocean crust, the oceanic crust is different in those locations to the northwest and to the south.
Yeah, because the South had opened 80 million years earlier. That's a lot of time.
Right. So the north and west of the plateau, it's Jurassic.
Yeah. And then at the very end is Triassic. No, which is Jurassic? The north.
The north and west is Jurassic. The southern is Cretaceous.
Okay. So in the Jurassic is when the bottom opens like this. And then it takes 80 million years for that final opening up at the top. That's a long period of time.
Wow, that is really long.
And the proto, they call it the proto-row. How do you say that? The proto-Atlantic? I guess it's proto.
Oh,
the pre-Atlantic, the one that wasn't open completely.
Yeah.
Yeah. So it only grew like not that much in 80 million years, but as soon as it opened in another 80 million, it's the Atlantic. That's two different speeds of things.
Wait a minute. Are we so the portion to the north of the Guinea Plateau is Jurassic?
That makes zero sense. The bottom portion was already open. It has to be older. Yeah, that makes zero sense. We'll get to
because the Atlantic is already there to the north of the Guinea Plateau.
That's another name of whatever ocean rushed in. That has another name.
Okay, but to the north, they're calling it the Central North Atlantic in this paper.
Oh, okay. I didn't know that's what it was called.
Right. So they're not using a proto-Atlantic. They're using a portion of the Atlantic that existed already, and they're just calling it the Central North Atlantic. So they're saying that area is Jurassic. The area to the south of the Guinea Plateau is Cretaceous.
Okay, so we're going to get to the bathymetric maps, and we'll figure out if they actually know what they're talking about. Because here's the problem. In a lot of these paleogeographic reconstructions like we're looking at here, so off to the northwest here, there's really no evidence that existed. They're assuming it existed because it rushed in.
Yes.
But here's the kicker. At this time and earlier, going all the way back 320 million years during the Akkadian orogeny. And remember, there's no seafloor that's that old. So we don't even know if there was any seafloor.
Yeah.
All of the continents had continental oceans on them. What are those?
Right.
They called them shallow inland seas.
Right.
But some of them were very deep.
Right.
It's very bizarre. The paleogeography is known, but they're assuming that there's big oceans that we have no evidence for that also existed.
We sort of run into this problem a couple of times as I was reading this paper. Like, for example, there are assumptions about, what the Earth looked like at this time that feed into the climate picture that we have for a particular period of time. And so then based on what we think the Earth looked at that time, and then it changed, they'll say, oh, so then it caused this other climate change later based on the subsequent change that we have evidence for. But if we're making an assumption about what the Earth actually looked like, we don't really know that that relationship is accurate.
Yeah.
You have a lot of knowledge being built on top of assumptions, and so it raises a lot of questions for me. But
yeah, so here is the paper we're talking about. It is, where's the date?
oh, it's
June 2025.
2025. I mean, it's basically just published, even though it's not June yet. But
Yeah, it hasn't come out yet. We are actually recording this from the future.
Yeah.
So
there is a full preprint though, so there's that.
Don't get scared because it's coming. So the paper is early Cretaceous deep water bed forms west of the Guinea Plateau, revising the opening history of the equatorial Atlantic Gateway. So you can get this for free. We'll link you below. This is not the entire paper. These are just.
We have a link to a preprint that we can put up though. That is the entire paper.
Is that this the DOI? Gotcha.
No, I sent it to you earlier on Telegram.
No, that's the same paper.
Yeah, and I went looking because this is behind a paywall. So, and then I found the preprint.
Now this is interesting. So think about this. This is right near the end of the dinosaurs, and the Atlantic has now split, and there's this weird ocean catastrophe happening, which is about to shift probably all of the weather patterns on Earth. When you get a change like this, you know, the biggest factors on Earth right now that affect our climate regularly, it's the ENSO cycle.
Yeah.
So it's La Nina and El Nino. It's where the ocean currents are moving, where they're taking the heat, and then where the moisture is deposited. With an entire global reworking of the ocean system, the whole world is going to go out of whack.
Well, right, because in the scenario that we're talking about, you know, we're talking about essentially that there was like a kind of a North Atlantic, a small North Atlantic, and then a South Atlantic that were separated, and this rift is what connected them. So everything would change at that point.
Yeah, and here is the fairy tale scenario. Okay. So here we are at the very beginning of the rifting. See that up on the top?
Mm-hmm.
And then somewhere between 170 and 100 is where that northern pinch point opened. And this fantasy ocean here over to the right rushed in to form the Atlantic. Mm-hmm. Now, look at the western side of the 170 million year old globe there. Mm-hmm. That is a massive ocean. Yep. It would take you like months to sail to the other side of the, I mean, that's insane.
Yeah.
Not to mention the Earth would wobble off its axis, I think, in this scenario.
Yes.
So I don't know if I'm totally buying that. But here is a cool jiffy I can share of that whole period and what supposedly happened. All right, here's the spreading. So there's the beginning, there's the crack, and there's now. Mm-hmm. This is all happening in the last 117 million years. And the current motion on the mid-ocean ridge, nowhere is there this much motion happening. Look at all that movement.
I know.
In just the last 100 million years. That is a blink of geologic history, folks.
Yeah.
If the Earth is 4.5 billion years old, that's nothing.
Yeah.
That is 1/4%. Isn't it? Yeah. Because 400 million.
It's funny because there was in the article that references this paper, there's a link to another article, and the title is, at least in the link, is "Sleeping Subduction Zone Could Awaken and Form a New Ring of Fire That Swallows the Atlantic Ocean." So they're talking about a subduction zone that's in the Strait of Gibraltar. I can never say that. Gibraltar. I have such a hard time with that.
Gibraltar.
Gibraltar. That makes it
Yeah.
easier.
Yeah.
That's been basically dormant for, I don't know, 5 million years or something. And based on some modeling they did, they decided that it seems like it might wake up and then over the course of 20 years subduct everything enough such that the whole Atlantic Ocean disappears, which I thought was pretty funny.
In how many million?
Well, I don't know. They say that it would be start. They're not really specific, but they say that it would start sort of swallowing up the Atlantic over the course of 20 million years. But they're talking about a whole ring of fire that swallows the Atlantic Ocean. Now, meanwhile, we have a ring of fire around the Pacific Ocean, which is not swallowing up the Pacific Ocean. Like, actually, in reality, the Pacific Ocean is still expanding. So I find that funny. Like, what's going to happen to all of that area?
Well, there's some areas there's mid-ocean ridges that are moving in the Pacific, and there's subduction all on the continental plates around it from that.
Yes.
Yeah. So let's get into some of the weird stuff. So this is a bathymetric map with ages of the ocean floor. And you can see purple, which only exists here in Africa in a very thin sliver, brings us over to that beginning of the Rift Lakes.
Mm-hmm.
And so there would also be some purple in here in the Newark Basin on the East Coast that's not shown on the map because it's on the crust.
Mm-hmm.
So what we can see is the oldest ocean floor is going to be blue, 160 million.
Mm-hmm.
And it's associated with the Atlantic, which is the newest ocean to open. You see how that doesn't make any sense?
Yep. Well,
so the newest ocean to open is the oldest, and the ocean that's been here forever, the Pacific, has the youngest rocks on the bottom.
Yeah. Not to mention the age of the ocean floor compared to the age of the Earth. Like,
right.
where is that giant ocean that would take months to cross?
Yeah, let's blow your mind.
That existed before all of this.
Are older than the oldest Earth rocks approach 4 billion years, which is somewhere near the formation of Earth.
Mm-hmm.
We've got 3.8 billion year old rocks that outcrop on the surface, on the crust.
Mm-hmm.
But the oldest ocean we have is 180 million years old. Mm-hmm. Again, a discrepancy of where is the 99% of ocean?
Mm-hmm.
Because even in the case when we have orogenic events that are closing oceans,
mm-hmm.
what happens is when the mountain building orogenies happen, typically a wedge of seafloor gets pushed up with the orogeny and it's still there. We have evidence of that for these orogenies, that there's seafloor pushed up on the crust.
Mm-hmm.
But none of the seafloor is billions of years old. We should have that.
Right.
And we don't have any of that.
Right.
Yeah, it's very telling. Very telling.
I mean, the only way that you could logically explain that, which still doesn't make any sense, would be to say that all of the continental crust has moved enough such that the oldest ocean floors are underneath the continents. But that obviously doesn't make sense because there's not even enough landmass for that.
Right. And there's huge evidence that there's huge crust and oceanic slabs on these gravity anomaly maps that are under there, that have gone under, but the length of the plate and the amount of that slab that's under there only puts it back a few 100 million years ago.
Right.
Not there's no 3.8 billion year old slabs of crust in the mantle anymore.
It's a problem that really screams at you right in the face. Right? Like that this has not been addressed by the geological community particularly is insane.
Right. And if you're just looking at this bathymetric reconstruction with time, and you use a simple model and you reverse it, you bring in the pink all at the same time to the orange. And then you bring in the yellow and orange all at the same time to the green. And then you bring the green all in at the same time. You get the beginning of the Atlantic. You get an Earth 50% smaller, and you get an Earth that is all continental crust with inland seas, which is what the geology shows us. So this would suggest that 180 million years ago, the Earth was tiny.
I mean, it sounds insane, right? Based on everything that we've been taught in science, but it's also the only thing that makes sense here.
Right. Let's blow your mind some more. Because even if we extend out to the end of the green here, let's push this all back to just the green. The Earth is still tiny, 50% the size. That's 80 million years ago. That's the end of the dinosaurs. And then shortly after that, the Earth rapidly grew. Look at all this growth here in the Pacific. Look at all this growth here down here at this time period in the last 80 million years. This entire ocean, the southern Australian Ocean and the Indian Ocean, all formed recently.
Very recently. I mean, consider that, okay, so this paper, right, is basically documenting that the split, just at least between South America and Africa, started about 117 million years ago. Well, so much of this ocean floor is way younger than that.
Yeah, almost all of it.
Yeah.
That is like the oldest ocean floor once you get up above 120.
Yeah.
There's very little of that. It's just on the edge of the continents.
Yeah.
So what that suggests is that at the beginning of the dinosaurs, these animals that would never survive on Earth today based on its size and its gravity, they could have existed on a smaller Earth. And we'll get to the math later. But here, let's look at another version of that. So everything that's yellow, orange, and red is all in the last 80 million years.
Man, that key is so small.
Orange, yellow, and red is all 80 million. So all the seafloor is new.
Yep.
None of it is old. That's a problem. That's a huge problem.
Very glaring. It is, like I said earlier, it's right in your face.
The Pacific has been around for, a billion years, and it was always gigantic while all the continents were on one side.
Right. So why isn't the floor billions of years old? Like, why? How is that possible?
Yeah, the Pacific is all brand new. All this red is 20 million years ago.
Right.
So recently, there was no Pacific.
More recently than the Atlantic.
Yeah, the Atlantic
and
is
the Atlantic,
the old one.
This continuous Atlantic Ocean is at best 117 million years old at the oldest.
Yeah, that's crazy.
In its sort of open state anyway.
All right, so what's the explanation? Well, here, let me come here before we get into the expanding Earth hypothesis, which we do have another podcast on this. We did have, I forget, do you remember the name of the guy that we had on?
Right now, no.
It wasn't Christopher Dunn. That's the guy with the power plant.
Yeah, he's Giza power plant. We talked about this, I think it was 2 years ago, and I'm only saying that because some of the papers that I have on this topic, I can see in my files, have been saved there as of 2023. So I'm guessing that's, if you want to go back and look for a show that we did about expanding Earth, I think we did more than one, but that would be around 2023.
Yeah, and I'm working hard here. Oh, my camera's off. I'm working hard here trying to find. All right, so let's go here and we'll enlighten you all. The expanding Earth theory is not a new one. It is the original theory to explain what was physically seen by geologists, field geologists. And this goes all the way back to 1834. Can you believe that?
I mean, I can, but
and it also goes back to Charles Lyell. It goes back to 1889 to Robert Mantovani when he published the hypothesis of Earth expansion and continental drift. This is 70 years before they settled on plate tectonics. And the idea back in the late 1800s was that thermal expansion caused volcanic activity, which broke land masses into smaller continents. These continents drift away from each other because of further expansion at the rip zones where the oceans currently lie. So this is the idea back in 1900. Now, what that means is that there's got to be some type of material being formed at the center of the earth that wasn't there before.
Mm-hmm.
And they're claiming that by some process they didn't understand then, thermal expansion, they're calling it, of magma, it's expanding the earth and then welling up at these fissures, which we call mid-ocean ridges.
Right. I mean, and one of the problems with that is if you go with that what you're going to end up with is an Earth with a lower density than it was before, or big, big pockets, empty pockets, and that's
styrofoam Earth.
Right. That's a problem.
But they didn't have any of the type of thinking that we do today.
Yeah.
So what we have to now do is train ourselves. My browser lost connection.
That's strange.
Can you see the screen?
Yeah.
It says it's sharing it. Okay. So what we now have to do is train our mind to think of what we know about the Earth. We've got an auroral belt at the north and the south that happens in a certain circle. This is the ring of the Birkeland Current, which connects to our sun and other planets. We are magnetically connected through the poles of other objects in our solar system. Everything's connected.
Mm-hmm.
And that somehow it is these circuits, which are like extension cords, which bring matter in the form of ether from one body to another.
Mm-hmm. And
then that would go straight into the core and somehow transmutate into more mass. So whatever the inner and outer core is, we have no idea. We claim it's liquid nickel and spinning. That is the area where this transmutation is occurring and mass is being built.
Well, but it, we're also literally taking in mass in the form of cosmic rays, which are mass particles.
Well, the dust is the biggest thing, but it's negligible. We did a whole calculation on it. Like over millions of years, we'd only gain like an inch on the surface or something.
No, on a regular basis, yes. But yeah. What if there was some kind of massive event that caused us to take in huge amounts of cosmic radiation at the poles?
Yeah, we could have a massive, yeah. So it could be twofold. It could be coming from the center and it could be coming from space.
Yeah. But also, I mean, let's not forget, right? Energy and matter are the same thing.
Yeah.
There's certainly truth behind E equals MC squared.
Right. And with the Sapphire Project, if in fact they're not lying, plasmas transmutate elements.
Right.
They don't know how it's happening. All they got is hydrogen in there and plasma, and then they've got all these other elements at the end of the experiment.
Well, and this is interesting, right? Because, we have the old model of the sun, which is, that this is like a thermonuclear reaction, right? That is literally creating elements versus a plasma, what you just said, this plasma idea that it is creating elements. And so if we look at our sun as like a plasma, I don't know what to call it, an operation of some sort, we literally get every element on the periodic table from the sun. It doesn't come from somewhere else.
And every single atom in our solar system would have been generated by our sun, including all of the water.
Yes.
Probably less than like 1/100% of our solar system is from out of the solar system. And it comes from very rare rogue objects. And only the first one we've ever seen, Oumuamua, is recent. So only recently did we understand that there could be objects from out of our solar system that enter and then leave.
Mm-hmm.
And that might be a very bad thing or a very good thing, depending on where these objects are coming from.
Low probability thing.
Say what?
I think it may just be a very low probability thing.
Yeah, but it could be very bad if it's coming from some weird solar system or galaxy that's not ours and has all kind of stuff that's not, that we don't have.
What are you suggesting, that other solar systems in the universe have a completely different set of elements, perhaps?
I think all the solar systems in our galaxy have the same elements. The galactic core, it determines the elements.
Yes.
But I think that there may be other things happening in other galaxies that we're unaware of. Because the only thing we're looking at when we're looking at spectra is the known elements here in our Milky Way galaxy. How do we know that there aren't other elements that are unknown? We wouldn't know how to look for them.
Well, and it's interesting, right? Because when we look for the elements of some faraway object, that we're nowhere near, we use things like mass spectroscopy, et cetera. Well, is it possible that we're just interpreting our results the way we know how to, based on what's in our own galaxy? Or, could those results be an indication of something else?
Yeah, there's just so many unknowns. There is no way anytime in the near future we'll know what the elements are in nearby galaxies. They're too far away. Unless we'll get above light speed travel in the near future. We would never know.
Well, it would be very interesting to see if there's, obviously we can only do it with the tools that we have and what we know how to interpret. But if we had an idea of what Oumuamua is actually composed of.
Why didn't we go out and get some of that?
Right.
It was traveling clearly too fast.
Right.
It was like in and out.
Well, and maybe that would help explain too, right? Like on our periodic table, the way it's structured is problematic, right? We have it in this sort of flat, linear, sort of rectangular shape thing. And we end up with this problem, right? Where we'll have like an area in here, and actually there's like 10 more elements that fit in here. Also, we have the problem of like, sort of missing elements, elements that should be on the periodic table, but we can only create them for like a split second or something like that. So maybe all of those missing elements are somewhere else in the universe.
Well, that's because we don't know how to make stable isotopes. We're not that smart yet. Like element 115, we did create it in a lab. It was speculated by Bob Lazar in the 1990s that this was the element that extraterrestrials use to power extraterrestrial spacecraft. But when we discovered it, it only lasted for a billionth of a second.
Well,
because it was not the stable isotope, which he says exists. And many people think he has pieces of it.
Okay, that could be.
Yeah. So if you're
another
an extraterrestrial race that is far more advanced than us, your periodic table is going to go up to 290. It's not going to end at 135 where we are. So we've only gotten like up to 135. We were at 116 in 1950. Then we found 117. Then we created 118. But all these elements like Einsteinium and all these things, they're only existing for a millisecond because of radioactive decay.
Yeah. Well, part of what I'm suggesting is like, it may not just be our lack of skill. It may be, and we've had this conversation before, it may be that certain elements are not stable in the conditions in which we live.
Right.
Like perhaps in some other set of conditions, in some other part of the universe, perhaps those elements are stable. I'm a big proponent of the whole structure of the periodic table probably needs to change because it doesn't make much sense the way it is. It does, but clearly think not everything fits in there.
Who's that crazy dude? Terrence Williams? Is that it? It's a black dude that claims he rediscovered the actual periodic table. He uses resonance and frequency
Okay.
to
Yeah.
relist them.
Yeah.
And it's way more eloquent, but no one knows what he's talking about.
I'd like to check that out. I was also thinking recently that, and without it playing around with anything, that if the whole periodic table was more like a cone shape, it would probably make more sense.
Oh, cool.
But anyway, that's another.
All right, so here's a cool map. And this is what I did at university, Paleogeographic reconstructions. Where are you going? Leah has left the building.
Sorry, I was just preventing a disaster involving felines.
Oh, okay. So this is the Paleogeographic reconstruction of the Akkadian orogeny. This is 320 million years ago, when Africa slammed into South and North America, supposedly. The brown area here is the massive Himalaya-like mountain range that would have been pushed up. And what's interesting is all the dark blue on this map, there's no evidence for it.
Mm-hmm.
Again, look at how big of a problem if all of the dark blue has no evidence for it.
Mm-hmm.
How in the world, why would you put it here?
Right. Well, and of course, there's also the much more basic physical problem of a globe that is situated like this. The spin of the Earth would be completely unstable. It's like having a spinning top with like a brick on one side. You know?
Yeah. Yeah, but that is only a factor if we're using the standard model of cosmology and Earth is spinning in a gravitational model. I don't think that's happening at all.
Mm-hmm.
I think we're stuck in an orbital. I think we're stuck in a magnetic orbital, so it doesn't matter how the Earth is oriented. It's stuck here due to its magnetic potential.
Yes,
and so
which is the same thing, just for our listeners, is the same thing as how we talk about electrons orbiting the nucleus of a atom. It's the same thing. So you literally get stuck there because of the electromagnetics. The electromagnetics determine which orbital shell you land in. You put energy into that molecule, and you're going to have electrons jumping orbitals.
Right. So let's say we could 86 Venus, because that's the biggest news topic, right? Let's not 8647, but let's 86 Venus. And so if you were just to take Venus out of the solar system and disappear it somehow and put it somewhere else, what would immediately happen if, in fact, we were in an orbital is all of the planets would rapidly move to a new position.
Mm-hmm.
And no one knows where that would be, because maybe as they pass, they would interact, creating more magnetic complexity, and something weird would happen, but then it would come into stasis and then it would stop and be locked there again.
Which actually works quite well with, Velikovsky type ideas. Like if Venus was actually once a comet that was trapped by our solar system, the idea is that shifted much else in our solar system. It wasn't just the addition of a planet, but everything kind of went awry for a while.
Right. So in Velikovsky's model and some of the Thunderbolts guys' models, what you have is something happening. In our solar system is stable, and let's say we come in with Saturn and Venus and Mars. We're a different solar system. We're traveling alone in a brown dwarf system in a polar alignment. So we're not rotating around Saturn. We're stuck in the polar orbit. All of the planets, but there's still everybody's spinning in a stick. Like it's like a stick of planets spinning.
Well, and your spin is going to be like this. Like if Saturn's up here, it would be like Earth would be at one.
We're all locked in the pole. So everything rotates along the same axis.
Yeah.
Right. All the planets have the same axis. It's weird.
Yeah. Yeah.
And then as you enter our solar system, we are going to wreak havoc. So the idea is that this rogue brown dwarf system entered the solar system, and either Jupiter became unstable because it's the biggest, most magnetically complex thing in our solar system, and it shot out its core. to stabilize the planet. And the core was Venus. And it left that red spot on the planet, which is still there. Now, Venus is shooting towards the sun like a comet. And all the mythology shows this.
Yeah.
There are accounts of people understanding that there's a scar on Mars. How did the ancients know that there was a scar on Mars unless Mars was very close and we saw it? So Venus shoots out of Jupiter and it starts moving by in our inner solar system and disrupting the patterns.
Yeah.
Now, what's weird is that Earth has been in the Goldilocks zone for hundreds of millions of years, so it really didn't affect Earth much.
Yeah.
It flew by Earth, maybe knocked Mars around, could have fried Mars into its current state due to plasma discharge, but it missed us and just nestled itself in its orbit where it should be, nicely inside the orbit of Earth, in between Earth and Mercury.
Well, I mean, there's lots of alternatives to make this work. Like you could also say that this occurred, sometime around the beginning of Earth's existence, for example. I mean, because then you could say, well, there's your being in the Goldilocks zone for hundreds of millions of years.
Well, that's the problem with that, is that all ancient cultures describe weird things that
Right.
have to be recent.
Yeah. Well, let's not forget too, and I don't remember exactly where this comes from, but isn't there a fair amount of mythology that talks about the sun rising in the west for some period of time?
Yeah, or the sun standing still.
Yeah.
That would that would happen during this event.
Right. So it would be, because everything wants to be in stability, right? I mean, this is how like an atom works. Like it wants to be stable. It doesn't want to be in chaos, so there'll be some momentary chaos and then things will land where it works electromagnetically. But in the meantime, you're going to have chaos.
Right. And the Earth standing still is more recent in antiquity. So it's not like evidence of any tilting of the Earth or anything. No, it would be during this planetary flyby, the Earth is magnetically affected and literally could just stop spinning for 7 hours or whatever. As Venus moves by.
Maybe.
And we're going to wrap up here real quick, but let's just give you a little tidbit before we go here. We asked Grok that what would happen if the Earth was 50% smaller, and it told us that the gravity would be exactly what we needed to have dinosaurs. So that is interesting.
The gravity would be half as strong.
Right. And that would be 220 million years ago, right when the Atlantic began opening.
Yeah.
So
funny how that works.
That's food for thought. Guys, support freedom of speech. Make a donation at revolution.radio and listen to us every Saturday, noon Mountain Time.
And also find us on Rumble on Magnetic Reversal News at 8 p.m. Mountain Time.
Great show.